Good day, viewers. Welcome to Class with Kelly. Today, we're going to study hypergeometric distribution under probability distribution. That is will be the focus of the video today. Well, hypergeometric distribution, which is one of the discrete probability distributions we have, just like binomial and Poisson, which means that we're going to calculate probabilities for discrete random variables, that is whole numbers, countable numbers, to summarize it, Okay, so hypergeometry moves a little bit like binomial. Binomial, we have a sample that has specifically two things in the sample, probably something in its opposite most of the times. But hypergeometry is almost like that. For hypergeometry, we don't only focus on a sample, but we say there is a population size, right? A population where in that population there are strictly only two characteristics of elements in that population. And it does not have to be necessarily something in its opposite. It can be just any two distinct characteristics of elements in a given population. Let's say that we have, let's say, students as a population, where we have, let's say, boys and then girls as students in a population or in a given number of people or students. Or we can have, let's say, cars, where we have just two specific ones in the, let's say, Mercedes-Benz and then, let's say, Audi, right? Or any particular definition given or population used here where there are only two distinct types of elements in a particular population. That focuses mostly on hypergeometry. So hypergeometry has a population, and then in that population there is a selection, there is a random sampling with replacement, although there is a random sampling. And they'll ask you that in the sample, what would be the probability that any of the characteristics in the sample or in the population is in the sample, all right? So an example would be where I'm using the students here. So let's say a population of students, let's say a population of 30 students, and then there are a number of boys in there and a number of girls in there as students. And they'll be like in a selection of, let's say, 10 or 7 students, what's the probability that 3 of them are boys or 2 of them are girls or whatever. That is how the focus of hypergeometry is like. So there is a population, one, and that population has two specific or two distinct characteristics of the element in there. All right. And there'll be a sampling out of the whole population at random. Now, in that sample, you'll be asked to find a probability that any number of the things in the sample is either of the things in the population. All right. I'm sure you get the focus of hypergeometry. So for hypergeometry, there is an interaction of a population and there's a selection from the population to get a sample. All right. So, like I said, there is a population size, which we use capital N for. Capital N to note the population size. There's a sample size, which we use small n. I'm sure you're aware that under statistics, when you see a small n, it stands for a sample size, right? Yes. So what you're saying is this: under hypergeometry, or for you to identify that this question or this problem is posing in a hypergeometry illustration, there will be a population or a given number of things, a discrete number of things. Let's say n as a population, and in this population, there will be only two different things over here. Unlike binomial, where mostly it focuses on an item and its opposite, and hypergeometry, it can be any two distinct things in a population, and there should be only those two distinct things. That is what matters. So, in this population, if it is about students, like I'm saying, if this is about students, then I'm definitely going to have, let's say, okay, let me say we have a finance students instead of boys and girls. So let me put something else. Let's say finance students, and let's say human resource students. That in this population of students, the only number two distinct characters among the students is that some of them are finance and some of them are HR. That is the only thing in there. All right. And then in this population, there will be a selection at random. All right. And I'll give us a sample because a sample is a random selection from a population. So when it's a sample selected from this population, they'll ask you. So let's say there's a sample selected, a small n. They'll be like, what is the probability that any number of students in this sample is either a finance student or a number over here is either a human resource student in a particular order. That is how hypergeometry mostly are like, right? So let's quickly dive into how to calculate and then some of the formula and how to deal with it. Because this is all about it. A population where there are only two things, a sample with the same two things, you have to find a probability that any number of the things in the sample is either one of the characteristics in the population. Are we okay, please? Fantastic. So I'll put the formula down, the formula in finding the probability and the hypergeometry. Then I'll explain it and then we'll see how to solve question like that. So to calculate for probability, under hypergeometry, that means find the probability of any random variable as the combination of x and capital X and small x. So let me do this quickly. Right. So this is the formula. And then the capital N is a population size. The small n is a sample size. Now, the capital X and the small x, let me explain that. In between this is a multiplication sign, the dot that signifies multiplication. Right. Now, the big X here and the small x here, let me explain them significantly. While the big X and probability is called number of successes in the population, and then small x is called number of successes in the sample. Understandably, what these things are this. So I've mentioned that in the population, there are only two distinct characteristics in there. Now, capital X here just stands for one of them. That's all, right? Capital X stands for one of them. So if, let's say, we have 30 students in a population, and that is our capital N, right? And then we know clearly, the question will define clearly the number of two characteristics in that particular population. It will be defined clearly. So let's say, in the example I gave, let's say we have 20 of them to be finance students, and then we have 10 of them to be HR students. Now, human resource students. So in this case, X can either be 20 or can be 10. It depends on what the small x is. Over here, please. Yeah. And I think so the small x over here, which you have as number of successes in a sample, which sometimes or most of the time I also define it as what you are calculating the probability for. The small x, it doesn't change. What you are calculating the probability for. So let's say I ask that a sample selected from this 30, let's say we have 10 students selected. And this becomes the sample size, clearly, right? So 10 students select out of the 30 students. In these 10 students, there are a number of finance and a number of HR students in here. Are we here, please? So if the question is, what is the probability that 2 students in the sample are finance students? A question, what is the probability that 2 students selected are finance students? 2 students selected in a sample, obviously, are finance students. And because we are asking about 2 students being selected, being finance students, that means our small x is focusing on the finance students, which means our capital X, which is the number of successes, what we are calculating probability for in the population. Since small x is on finance students, capital X will be the number of finance students in the population. That's how it works. So in this case, capital N becomes like 20 because that's the number of finance students I'm explaining in this particular population over here. Are we here, please? And in an instance where the question rather changes and asks that, what is the probability that 5 students selected are HR students? In this case, what is the probability that 5 students selected are HR students? So I'm looking for the probability of 5 students being HR, 5 students being the small x, focusing on HR, and the capital X becomes the number of HR students in the population, which in this case becomes 10. I'm sure we get it. That is the definition of the capital X and the small x. So whatever the small x is focusing on, capital X is that number of people or that number of elements in the population. I'm sure that is clear. And that's how what these things mean. And that's the formula for calculating hypergeometry. And then, so if we've gotten it, let's see a problem, right? So we have the combination of capital X and small x and the combination of N minus capital X. So if this is the number of one side of the population, capital N minus capital X will be the number of the other side of the population. And then small m and a small x. So you've put everything in here to be able to find a particular probability. So I'll give an example and then we'll see how to solve it, all right? Okay, so we'll try this question over here. For a company of 50 staffs, where 28 of them are accountants and the remaining are human resource personnel, right? So 30% of the staffs were selected for an online training to be hosted at the company's premises. So what's the probability that A, 4 of the sampled were human resource staffs, B, none of them are accountants, C, at most 10% of them are accountants, and then D, not less than 5 of them are HR staffs. Quickly we'll solve this and then we'll see what we have here. But in the question, see how the question was created. So a company of 50 staffs, where 28 of them are accountants and the remaining that means in the population of 50, there are only 2 people there or 2 characteristics there, accountants and then HR, right? So I think here we can clearly see what the capital N would be. And that would clearly be 50. That's the population size, right? Then we're told that 28 of them are accountants and the remaining, that would definitely be 22, right? 22 of them will be HR students, and that will be the remaining if 28 are accountants. Then as well, we're told that 30% of the staffs were selected for an online training. Please let's take note, this is a percentage, but it's not probability. is giving us the number of staff that were selected. This is giving us the sample size. So 30% of 50, which I believe is going to be 15. The sample size is going to be 15. That's 30% of the 50 staffs, if I'm correct. Now, so we have this two over here. So if I should solve the A, where we have four of the sampled are on human resource staffs, and we know that this 4 here becomes the small x. That is the number of things we're calculating the probability for. So for A, our small x is 4. However, our small x is focused on the human resource staffs. So like I said, whatever the small x focuses on in the sample, the big X has the same focus but in the population. All right. So here, the capital X for the A becomes the number of human resources in the population, and that will be 22. Since 28 are accountants, and we're told the remaining are human resource personnel. Right. So this will be what we'll use to get the first part that. So the probability of 4 of them being HR is going to be the combination of the formula is up here for reference 22, and then we have 4 times a combination of we have 50 here, and then we have 15 here. Sorry, that is 50 minus 22, and then this also gives us 15 minus 4, all over the combination of capital N 50, small n of 15. So if I should make this simple, I have a combination of 22 and 14 and 4. Find the combination of 28, and then this will give us 11, all over the combination of 50 and then 15. So if we should quickly put this on a calculator, we're going to have. So let me quickly punch this and see what we have. Having the probability of 4 to 0.0697892, and it continues in a particular order. So this becomes the probability that 4 of them are human resource staffs. Okay, so we'll go to the second one and then see how it's up. I'm sure we get what we've done here so far. Right. So the B says that none of them is an accounting student, right? None of them is an accounting student. None means 0, right? So the same progression. But here, the none of them is on accountants, not the HR again. So if I'm to do that, the B, so I'll solve the B right over here. X becomes 0 because we have none of them. And then capital X, since it's accountants, becomes 28, right? So that if I should rewrite this quickly, I have the probability of 0 to be equal to the combination of, we have bigger X, so that's 28 and 0 times 50 minus 28. And then I have 15 minus 0, all of the combination of 50 and then 15. So that if I should make it simple by dealing with the subtractions, I have a combination of 22 and then 15, all over the combination of 50 and then 15. So we just have to punch this and then we are there. Okay, so this becomes the answer to the B, where X equals 0, right? So you can either put it this way or put it this way if you want to leave answer in standard form, right? Yeah. Okay, so then we can deal with the C. So the C and the D, you can clearly see that for them, X is given in ranges, not just a number, like the A and B, where we have 4 of the staffs or none of them or whatever you. C is at most 10. And we know when we present these things, this at most, at least, and all of the instances where we have the inequality symbols there, then in that case, we are going to have to apply the cumulative probability, right? Yeah. So we'll define our range. Every time we have things like this to solve them, you have to get the range of your X, and then you see how to work around it. So here, we are looking for the probability of at most 10 things, not just one item. So let me quickly clean this and let's see how to focus on that quickly. So our X here for the C is at most 10. At most 10 means less than or equal to 10, right? So X is less than or equal to 10. That means that the range of X is going to be from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. This will be the range of numbers for my X. And the capital X as well for this case. We're told that at least 10 of them are accountants, still our accountants. So capital X will be the number of accountants in the population, right? Now it'll be 28, as defined in the question. Now, when you have a cumulative probability like this, what you have to do is to find the probability of each and every number in a range. Then you add the answers. So like we did for the 4 and the 0, we'll find the probability that X is 0, X is 1, X is 2, on to 10, then we'll add all of them. That looks work, right? It looks like a tedious work. Yes, that's what you have to do. But there's also an approach on a calculator that we call the summation approach that we can use to do something like this as a goal without having to do them individually, right? So if you don't want to do it individually to add your answers in that case, you can use the summation approach. That says that, but the summation of a higher range and a lower range for a particular formula. I'm sure you've seen this in a calculator before. This guy's calculator, and it's also a function in mathematics that we use. So this is used to find the sum of a repetitive calculation, right? Yeah. So what we're going to do with this particular function here is that this is the summation function, right? We'll put a formula for hypergeometry in the bracket. So this is used not just for hypergeometry, it's used for any time we have to do apply a particular formula on different numbers and we add them, right? We use this particular function to do it as a goal. So we'll put a formula in the bracket. Then the two boxes over here, I wrote it this way because this is how the calculator puts it, the scientific calculator puts it. We'll put the highest range in what we have defined over here. Then the lowest range is what we've defined will be down here, right? So if I'm to write it for you to see how it will look like, this is how it will be. So the probability that x is less than or equal to 10 will be this. I have sigma, x be the lowest value is 0 over here, the highest value is 10. So I have 0 here and I have 10 over here. And I put the formula for hypergeometry in the bracket. It's going to be a little big, so I'm putting a big bracket over here, all right? In the formula, we have a combination of capital X, that is 28, and a small x. So when you're putting the formula in the bracket for a summation, you write x in there, all right? I'll show you how to punch that. Times a combination of, so we know 50 minus capital X, right? And 50 minus capital X, 50 minus 28 will give us 22. So I wouldn't want to write that in here. So I'll just write the 22 over here. And then I have n minus x. So that will be 15 minus small x in this case. All over, I have a combination of 50 and then 15, right? Good. Now, you would have to use the scientific calculator to punch this significantly, all right? So this is correct, but I'm going to write it in the way that it will look like on the calculator. So on the calculator, it should look like this. If you punch it on the calculator, it should look like this. For you to get the accurate answer, x is 0 here, x is 10 here. I'll have a bracket, or be a fraction. Now, whenever you're punching a combination, which is multiplied to something else, you have to put each on every one of them in brackets. So I'll have a bracket, 28 combination x, right? Then I have times. You have to put the times here. It's very, very important. Another bracket, 22 combination. Now, this is where it becomes interesting. You can see there is 22 combination. Another expression is over here. So this first bracket is for this one over here, right? Then 22 combination. And I have another bracket here for the 15 minus x. And I close it. And I close this bracket again. It will look like this. So a bracket, 22. This is a bracket. Sorry, this is a combination symbol. Let me write it. Let me differentiate the combination from. Let me do it this way. So we get it. Different from the brackets. So I'm using this block C as the combination symbol, all right? I'm hoping you wouldn't get confused. So this is 28, so a bracket, 28 combination X, bracket closed, times a bracket, 22 combination, another bracket for this one, 15 minus the small x, then you close it. I'm sure you can punch the X on the calculator. I think alpha and then closing bracket will give you the small x. So this bracket is just for the 15 and the small x, but you open a bracket here. So you have to close that bracket first. But don't forget that the sigma already gives you a bracket. So we are working in that sigma bracket. So don't go outside the sigma bracket, all right, or the summation bracket. Now I'm done with the numerator and I come down to punch a bracket of 50 combination 15, right? Yeah, so this is how it will look like if you're punching it on a calculator, right? When you're able to punch it this way, it gives you the accurate formula. If not, you have to find the probability. You have to use a formula, find the probability of 0. So you put 0 here, you put 1 wherever you see x, put up to 10, then you add your answers, all right? So either ways you choose to apply, you get the same thing. So after calculating this, we have our answer to be 0.90514507, and it goes on. But approximately, this becomes the probability for the C. At most, 10 of them are accountants, right? So this is just applying the summation rule or the summation function and solving a cumulative probability. I'm sure we're okay with that, please. Right. So on to the last one, and then that will be the end of hypergeometry. So not less than 5 of them are HR staff. So the same progression here, but here we have a different definition for the X, not less than 5. If it is not less than 5, then it is equal to 5 or greater than 5, right? So here, if you are done putting this down, so I'll still do it here. My D, I have the X to be not less than 5. That means it's greater than or equal to 5. Now, this means that we have from 5, our sample size is 15. So it's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 15. You know, when you are defining the values to higher numbers, you have to end at the sample size, right? Because that is the number of things selected. You can't go beyond that. So we want to find the probability that x is more than or equal to 5. So we can put the same thing in the progression and then we go on, all right? However, there is another way to deal with this, as we know. So where I have x to be more than or equal to 5, and I know that that set is quite big or long or has many elements in there, because from 5 to 15 is a lot of elements. Where we also know that in a given sample, when we add all the probabilities in a sample, we get what? 1, right? The sum of probability elements in a sample is 1. In that case, we can find the other part of the set that makes it a total sample. The other part of the set that makes it a total sample. Now it's clearly 0, 1, 2, 3, and what? 4, right? This is the other part that makes it a total what? Sample or a complete sample. So we can find the probability of these ones individually, then we add them. When we do that, we have to subtract that answer from 1 in order to get the probability for this over here, right? So in case you don't want to do from 5 to 15, you can do from 0 to 4, then you subtract that answer after you have added the probability separate from 1. I'm sure you get that, please. Yeah. So any of them, you will get the same answer. But since I'm using the summation rule, I'll do the 5 to 15, and then we'll get it done. I think I'll also do the 0 to 4, so you also see how that also plays out. So come with me, let's see how that will be done. And here, we are focusing on 8R students, right? Not less than 5 of them are 8R students. So since they're 8R students, the capital X will become 22. So our capital X here becomes 22 for the computation. So we're going to have something like this. The probability that X is greater than or equal to 5. So I have a sigma X equals the least number we have. So I'm doing this first. That's 5. And then the highest number is 15. I have a bracket. So I have a combination of the highest number of X, that's 22, and then small x. The combination of, we have, so 28, that's 15 minus 22, right? 15 minus 22, 28. And I have 15 minus small x, that's small n minus small x. The combination of 50 and then 15. Yeah. So after punching this, we have 0.905. So I have 1450727. So approximately, we have this as a probability if we should do it straightforward this way, right? So you see, this is quite short and then very understandable, right? But if you wouldn't want to do the 5 to 15, you want to go the other way around, you can also do 0 to 4, then you subtract that answer from 1, right? So you can put this down quickly, and then we'll see how to do that one as well, okay? So let's see how to do that one as well. So for that instance, that will be the probability of x being when we go to 5, will be equal to 1 minus the probability that x is less than 5, right? It will be like this, okay? Because this is x less than 5. So find x less than 5. So the sum of the probability of x less than 5. So find the sum of these probabilities and subtract the answer from 1, right? So let's find this, then we'll subtract from 1. So sigma of p x less than 5 now will be equal to, I'm using the sigma function again. So x will be 0 here, and then 4 over here. Because my least number is 0, my highest number is 4. I'm sure we get that, please. The combination of the same thing, nothing changes here. So 22 and then x times the combination of 28 and then 15 minus x. All over combination of 50 minus, and then 15. So whatever we get here, the answer we want to find will be 1 minus this over here, right? So let's get that point down. So I think that should give us 0.04, 0.09, 485, 49273 in that particular regard. After punching just this part, we're having 0.09485. This is decimal. So after then, like we said, we're subtracting that from 1. So I have 1 minus this one, and that gives you back your 0.90514 50727. Right. Yes. So that's how it's done. Right. Yeah, that's how it's done. So remember, for hypergeometry, there will be a population or a particular number of items where there are strictly 2 distinct characteristics in that of elements in that particular number of items. Then there will be a sample selected or a random selection, random sampling, or what have you, right? And in that sample, they'll ask you the probability that any number of the things over there are has the characteristics of the ones in the population, like we have here. So example being accountant or HR, an accountant or HR, the same thing in the population over here. I'm sure you get it, please. And that is how it is done, right? Yeah. So thank you for watching. We would end hypergeometric over here. Hope to see you. Don't forget to like, subscribe, and then hit on the notification button so that you're updated on any video when it's uploaded. Thank you so much.